Yes, in this embodiment here, what we're doing then is to give the open-ended discharge. We completely disconnect the Tesla coil, bipolar Tesla coils from the system. And instead, we give them bulbs. And on these bulbs, we give them routing. And there is the routing that we're employing now. One of them potentials is a globe, brass globe, about the size of a basketball, and it has a wire going down away from the source, and then directly underneath that is now the stand that holds the PVC tube isolated from the ground. Essentially what we're doing then is we're putting a 3-foot arc gap 25 and 28 feet into the air. Now then we connect that circuit to the bulbs procured from the high voltage from the system, and right there's the system. We'll be in there to show you that in just a second. There's 2 secondary coils. Each of them secondary coils vibrate from the underlying trifold pancake 3-phase primary system. And then we go back to this, we've been using some magnetic water in the garden in this year, and then we got to look at that real quick. Every year we grow morning glories. This morning the right-handed column fell down, and we prop it back up, and it's September 29th. Been a pretty good year for produce, eating off the garden and everything else, you know, hey Ray. And wanted to get some capture of these. Every year I try to grow 4 trellises. You might be able to see that 4th one back there. That's a weaker one. Like I said, it's September 29th, everything's falling down. Yeah. Seen our praying mantises this year. The front one was huge. We're trying to get seed, and this seed was all 4 to 6 years old when we planted it. In the middle of summer, did real good. And so much for that, right? Hum hum. Now back to our scientific work now. Going in here and we're looking at the input. Well, Ricky. Okay, this is always a difficult point. I like to show what's going on before and after the field's turned on. Now, hopefully, we've got a lamp in behind there. I can tell you phase 1 voltage is not enabled. Should be able to read phase 2, phase 3, and all 3 amperages. I'm going to go up there and look at that and say that. We got 0.9 volts phase 2, 0.10 amps. We got 1 volt phase 3, 0.18 amps. We don't have more than phase 1, we got 0.13 amps. Now when we turn the field on, those values should be increased 12-fold, as it will be operating as a 12-volt source like it does in the car. 3-phase alternator. Yes, we got that far. Okay, we should go back up there again and note what's going on with that input. Got 8.2 volts establishing 0.7 amps. Got 8.5 volts establishing 1.2 amps. And we have phase 1 establishing 1 amp. Now, having established that, we'll turn that halide light out. Turn the halide out. We got the halide turned out. Now over here on the output end we can see then goes the outputs going to that isolated single-ended load. There's the removal of all exterior lighting. Now on that output then, right in front there is a 12-pound coil. That's the first coil we're monitoring. It's at least a foot away from the discharge tubes. Now we're going to be looking at that output. This would appear to be a cycle of 1.6 microseconds, and the voltage being registered by 10x probe is 20 volts per division. So here we got an appreciable signal like that coming so far away from the discharge tubes. So we want to be exercising caution about how we're going to be placing these coils around the discharge tubes, seeing the prodigious amount of voltage being released by the fine wire model. It'll be good to go up on a frequency sweep, if we might, show the continuity of the vibrations from the 465 Hz source. I think we started out at 1 microsecond. It's a 1.6 microsecond cycle. We'll go up on that. Those are all at 10x values. Now we go in the other direction. Notice the complete continuity of high frequency vibrations being received by the coil. Rather incredible. Now, of course, this comes down to some 660,000 hertz or something like that. Inverse of 1.6 microseconds would be 600-some thousand hertz. And right now, then, we're going down on our voltage, our frequency selection knob. We'll try to show that. Try to figure out where it's set at. It would appear to be set at 2 milliseconds, which is the frequency of the decay. That's 1 millisecond, 5 milliseconds, and 5 milliseconds per switch on 260 Hz cycles going around, okay? Well, in our device, the 2 cycles of 60 Hz occur. Yeah, it doesn't fuck that whole thing up, right? Like I said, in our device, when 260 Hz cycle have gone across the screen. Instead, we have 16. You know, that's the nature of the high frequency being broadcast. By this new Prismark source. Well, the front coil is a foot away from one of them tubes. Now, of course, the next thing we want to do is get them coils up near the tubes now, right? That's what I would say. And you design the whole circuit according to the resonance specifications of the natural resonant frequency of each inductor. Here, then we can find a way to find out the internal capacity of that inductor. It will be good enough for now, then.